puddle down. This results in deep penetration and spreads the puddle out for a flatter weld bead. As the rod is angled, the arc force is directed more to the back of the puddle, allowing the weld to build up. If the rod is angled too low, the arc is directed right where you're trying to build weld, making the puddle hard to control. You will run into situations where you may want to flatten out the weld, or you'll need to push the puddle back more, so you'll use different rod angles. When you're starting out, an angle somewhere between 45 degrees and straight up and down is comfortable, allows a good view of the puddle, and works well for building weld bead. The rod size is a diameter measurement of the metal in the electrode. Common sizes are 332, 1/8, and 532. Most welding rod size charts, where they give the metal thickness to the rod size and amperage setting, are generally from the point of view of maximum weld in minimum amount of time, often not taking into account the welder's ability or different welding situations. You can always use a smaller diameter rod for better control. It just takes a little longer to build up weld bead. This is a 1/8 E6010 electrode, and this is the most common size used. The manufacturer's recommended amperage setting is from 75 to 130 amps. They're saying this rod will work over a 55 amp range. The specific amperage setting is considered a variable and depends on metal thickness, position of the weld, and the welder's ability. The whole purpose in arc welding is to get the base metals hot enough to melt, forming a molten puddle. If the amperage is set too low, the base metal doesn't get hot enough, and the puddle looks like it's following the rod around. If the amperage is set too high, the base metal gets too hot. The stronger arc force gouges deep into the base metal and pushes the puddle back. When the amperage is set about right, the puddle will spread out and the outside edges tie in immediately. You can ease the puddle around, kind of pushing it with the movement of the rod. Depending on each welding situation, the amperage setting can change. Thicker metal dissipates the heat, so you need a little more amperage. Thinner metal will get hot fast, so you can use a little lower amperage. The final amperage setting is determined by what the molten puddle is doing. You do need a place to start, so try about the middle of the manufacturer's recommended range, and don't be afraid to go up or down a little bit. Welding really is about the temperature of the base metal, so we can't talk about the amperage setting without looking at the speed of progression, or travel speed. The faster you move, the less time heat is put to the base metal, so it stays cooler. When you move slower, you're putting the heat to it for a longer amount of time, so the base metal gets hotter. When you move too fast, the metal doesn't have time to heat up, so the weld bead just skates across, not getting any penetration. If you move too slow, the metal gets extremely hot, causing the puddle to spread out, making it hard to control. When the travel speed and amperage setting match, the puddle spreads out, but it's still controllable. The sides tie in and the weld builds uniformly. As you gain more control of the rod, try using a slightly higher amperage setting and increasing the speed of travel. The higher amperage setting provides better penetration and a smoother finished weld bead. Try to weld as hot as you can control the molten puddle. To finish a weld bead, add a little extra metal before you pull out, to avoid leaving a crater that's below flush with the surface of the base metal. Circle the rod once or twice, then bring the rod up and back over the weld. While different rods may not look quite the same, these are the basic steps for all the welding rods. Scratch to get the arc going. Start the puddle wide enough to keep the weld a uniform width. Maintain a uniform arc gap with an amperage setting high enough to let the puddle spread out. Ease the gap with an amperage setting high enough to let the puddle spread out. Ease the puddle around using the force of the arc and watch the sides and the weld build up. Add some filler metal before pulling out over the weld bead. That's about all there is to it. For 60-10 in the flat position, try a circular motion and angle the rod to build up weld. Watch the molten puddle, not the light. Keep the circles tight for a smoother weld bead. A zigzag motion will produce about the same weld. Watch the edges to make sure they're filling in and ease the puddle back and forth. Because of the strong arc force and light slag, you can also use a whip or step motion, and this is what makes the fast freeze rod so versatile. The tip of the rod is moved back so the arc is actually brought out of the puddle. Then molten metal is pushed back in. With the step motion, watch both sides and the weld buildup every time you push the puddle in. This kind of rod movement can be used for deep penetration by digging down on the backstroke, then filling the gouge in. On thinner metals, where you don't need a lot of penetration, you can puddle, then long arc to let the weld bead cool, and puddle again. The thinner the metal, the faster this goes. The step motion can also be used to fill gaps in poorly fit joints. Keep the rod deep in the gap and bring it back, allowing the metal to cool. Then push a little more metal in to fill the gap and let it cool again. The step motion may not always look real slick, but it's usually covered with another pass. So far, we've been welding in the flat position. For a vertical with 60-10, you can run either uphill or downhill. Downhill is easier, but there's less penetration and weld buildup. Because heat rises, you're welding away from the heated metal, so you can use a slightly higher amperage setting. Watch the sides and the weld buildup. Try a circular, zigzag, or step motion and angle the rod up a little so the force of the arc helps hold the puddle up. With a circular motion, keep a steady arc gap and ease the puddle around. Move fast enough to stay ahead of the molten puddle. If the puddle wants to drip down, try moving faster, or maybe even a slightly higher amperage setting. When you weld uphill, you'll be welding into the heated metal, so turn the amperage down a little. Angle the rod up so the force of the arc doesn't blow the puddle out. An uphill weld really gouges into the base metal, making undercutting a potential problem. So pay particular attention to the sides of the puddle and watch the weld buildup underneath the rod. If the base metal gets too hot, the puddle may fall out, or you might burn a hole right through the metal. Mess with the amperage setting and your travel speed until you can carry that puddle right uphill. A horizontal weld is a cross, and you want to angle the rod to push the puddle up. Keep the rod nearly perpendicular to the metal or angle into the weld a little bit. If you angle the rod too far, the arc force can blow the puddle out. Using a circular motion, keep a steady arc gap and just ease the puddle around. Every time you bring the rod down, the molten metal will follow the heat. Make sure you push the puddle up and watch the top side. If the bead is wanting to sag down, try a faster travel speed to keep the base metal cooler. That leaves us with overhead, straight up and down. Overhead is about the same as welding flat, just a little more awkward. The real challenge is to find a comfortable position so you can keep the rod steady. Your welding hood should have an adjuster to help hold it up.